Hello everyone, my name is Manasvi Sharma. I am here to discuss and solve the following questions of computer-oriented numerical methods. So let's begin with the first question. Write an algorithm to solve following pair of equations for x and y given the values of a11, a12, a13, a21, a22, a23 such that a11 x1 plus a12 x2 is equals to a13 and a21 x1 plus a22 x2 is equals to a23. So we will be solving this question through Gauss elimination method. Let us first understand what is Gauss elimination method, through which we will solve the cases. Gauss elimination method is an iterative method to solve simultaneous equations. I will be explaining through the algorithm. So the first step of the algorithm indicates that firstly we will initialize by iterating for loop and will be initializing I by 1 to n in steps of 1. That means we are incrementing in each step. Similarly, we'll make the loop for j equals to 1 to n plus 1 in steps of 1 do. Then in step 3, read aij. That means we read all coefficients of x. Then we will be ending the loop. Then we will be following forward elimination steps. So the first step in forward elimination is here k is initialized to 1 and go up to n minus 1, where n represents the total number of equation, which is 2 over here according to the question. Now in step 6, u is initialized with aik by akk, where we substitute the value of aik by akk into u, where u is another variable. Then again we will be initializing by iterating the for loop and will be initializing j by 2k to n plus 1 in steps of 1 do. Then in step 8 we substitute the value of aij. Then we'll be ending the for loops for all the three conditions we have mentioned above. Now we will be taking the follow-up of back substitution method for finding values of x1 and x2. So here xn is initialized by n plus 1 by ann. Here xn, which is the last value of x, can be determined by substituting the value of n plus 1 by ann. Then we begin with an for loop. Then in step 10, for I equal to n minus 1 to n in steps of minus 1 do, which means I is decremented up to it comes to 1. Then sum is initialized with 0. Then our next loop starts with for j equals to I plus 1 to n in steps of 1 do, where sum is initialized with sum plus aij xj. We will put the value of sum, which is initialized to 0. Then we'll be ending the loop. Then we will be finding the value of xi with the help of ai n plus 1 minus sum by aii. Then we'll be ending the for loop. So by using the Gauss elimination method algorithm, we can find out the value of x1 and x2 in the below questions. Now we will be solving the cases to find the value of x1 and x2. First of all, we will be writing the equation that is given a11 x1 plus a12 x2 is equals to a13, a21 x1 plus a22 x2 is equals to a23. Now, first of all, we will represent it in augmented matrix format. Then, we will put following values of a11, a12, a13 and a21, a22, a23. Now, through triangularization phase, we will be eliminating some terms and forming a lower triangle. Now, let's begin with case 1. So in case 1, we will be initializing r1 by r1 upon 2.5. So this will make changes in row 1, that will be 1, 2.08 and 2.48. After that, we will be initializing the values to r2. where R2 will be initialized as R2 minus 1.251 into R1. So there will be the changes in R2. That means row number 2. So after triangularization phase, we get two equations, that is x1 plus 2.08 x2 is equals to 2.48, and then another equation is 0.00292 x2 is equals to 0.04952. So from equation 2, we get the value of x2 as 16.9589. Now we'll be substituting value of x2 in equation 1. We get x1 plus 2.08 into 16.9589 equals to 2.48. So the value for x1 is equals to minus 32.794512. Similarly, we will be performing case 2. So the values we get of x1 and x2 is x2 we get 12.63265 and x1 minus 23.795912. Similarly, in case 3 we get x2 as 1 and x1 as 0. Then in case 4 we get value of x2 as 1 and x1 as 2. So after finding values of x1 and x2 in each case, now we will solve the subpart of the question, that is the question A is comment on results of case 1 and case 2 when there is change of 0.001 in one of the coefficients. So the answer to this question is, we observe that there is a change of 0.001 in one of the numbers. The solution obtained for x1 and x2, where x1 is equals to minus 23.7959 and x2 is equals to 12.6326, a change in one coefficient by less than 1 in 2000 less to a change of more than 30% in the values of x1 and x2. So we get a point that here there is a change of more than 30% in the values of x1 and x2. Now let's see what the B part says. How interchange of equations affects the solution in case 3 and case 4. Interchange of equations affect the solution in case 3 and 4 by providing more accurate answer and less error in case 4. So this means that case 4 is more opt and accurate.